All right. Hi, good morning, good evening, good afternoon, wherever you guys are. Thanks again for joining us for Azure Data Week, and in particular, this session with Roland Gosling on modern data warehouse. We are right at the top of the hour, so we are going to go ahead and get started with Roland. If you guys need anything throughout the session, we'll be monitoring the chat, so please type it in the chat window and enjoy the session. You're good to go, Roland.
All right. Good morning, everybody. It's good to be up and around at this time of the day. Hopefully, it's not the middle of the night where you are. So I'm Roland Gosling. I'm the senior technical architect for data and AI at the Houston MTC. I began my career back at the Kennedy Space Center there in Florida a while back. I've been a techie since 1990, full time. And of course, I've consulted for many, many years, including our friends at Pragmatic Works and others. And also, I like doing SQL Saturday type events, so I try to get out and do those a couple times a year. And I love music. That's the other thing to know about me. All right. So I want to just take just a second and introduce you to the Microsoft MTC, since not everybody knows what that is. It's a place for our customers, partners, employees. A lot of times when I'm traveling, I can go to any MTC and drop in and work, and partners come there or customers come here. And basically what we do is help customers with design decisions and whatnot. So oftentimes we're engaged by the sales team. So if you have a salesperson that comes and visits your establishment, usually they know how to engage us. And we offer these following sessions, which I won't go into a lot. But basically, we're made up of a team of data and AI, infrastructure, app dev, and modern workplace, and we can help with almost any kind of solution. I wanted to talk a little bit about the kind of pioneers of older data warehousing a little bit. I wanted to start with Claudia Imhoff, who's a great person. She's out in Boulder, still around and still doing important stuff. She's kind of I would call her the queen of the ODS ID, the Operational Data Store. And she had some help too, so she didn't do it alone, but she's one of those people that doesn't get enough airplay from my point of view. This is exactly what I'm talking about here. This is one of her early articles that you can get off the Wayback Machine. You can see Claudia in all her glory there. She's been at this a long, long time. And part of why I'm taking you down this road is because in order to appreciate what we're going to say about the modern data warehouse, I think it'll help you to understand where we've come from. This is Bill Inman. She partnered with Bill quite a bit on some of their early stuff with data warehousing. You'll see a lot of times their names are kind of stuck together, but they are kind of smart people in their own right and have their own ideas. Never met Bill, but I've met Claudia many times. And this is Bill's main book that you'll run into out there in the wild. And this is Ralph Kimball, who I did spend a lot of time with. And Ralph is kind of the seminal father of what I think of as the side that won. Not everybody agrees with that. But so the difference between Inman's approach and Ralph Kimball's approach is Inman was famous for designing everything from the top down, meaning we would design data warehouses from the top down and basically present that to the user community as a kind of an approach. And then Ralph was the other opposite. We built those at the department level from the bottom up. I think that's why I feel like that the Kimball method was far more successful, because it engaged everybody at the department level and gave everybody an equal chance at the table to talk and kind of shape this thing that we call a data warehouse. And this is Ralph's famous book, along with Margy Ross, who's this nice lady. She's the one that coined a lot of the terms like not working in the kitchen, where nobody wants to know what goes on in a restaurant, as she's famous for saying, which is probably true. You don't want to see them when they drop that hamburger on the floor or whatever. But so Margy did a lot to shape Ralph's thinking and contributed heavily to Kimball's group. This is the entire Kimball Group before Ralph retired. He's now retired. They closed the business or moved on. I think Margy's working other places. Joy Mundy's over on the right-hand side. So kind of an interesting bunch of characters that ran that place. So we'll kind of get to the beginning of this thing. We had originally all these source systems on the left, like ERP, CRM, app data, still what we have today. And we have extract, transform, load kind of ETL there going on in the middle, all pointed towards an ODS, was kind of the early attempt at that, back to Claudia's sort of influence. So the operational data store is kind of where a lot of this began for people. And that kind of did a couple of things. It gave us a common place to look for data, and common place to offload reporting, so that before this, what you would have and still have in some cases today, there are people pointing reporting type resources directly at the databases in production and causing pain as far as performance and locking and security issues, all those things combined. So we got away from that by using an operational data store, and that kind of begat the data warehouse. And this is kind of the traditional look at data warehousing as we've known it for a while, where we've had, here are the source data systems on the left, and they're feeding into a staging database, and then the ETL solution is going to carve that up into facts and dimensions, which we can talk about some. We may have department level data marts that are fed from the data warehouse that are over on the right, and ultimately an OLAP cube of some kind. For us in the SQL Server world, we all know that as analysis services. And these days we have two flavors of that. Obviously, we have the tabular model, which is the current rage for all the kids. And then before that, we had MDM, the multidimensional type, which I know, folks like Adam there at Pragmatic Works is a god amongst many out there on that score. I know he's written several books on that topic. So if you really want to talk to someone smart about analysis services, get a hold of Adam Jorgensen there at Pragmatic Works. So as we move through this thing, you can see with the extract, transform, load side, and the refresh, and all the bits that have to move through this thing. And so as the refresh happens, there's a lot of moving parts to this piece, and we're going to talk about a couple of more current ways to look at this. Not necessarily better, but different, and I will kind of get into that. So when you get the final big picture of this thing, this is what it looks like now. And one thing that I want to mention is that using the Kimball method, the star schema has become ubiquitous. Most tools seem to understand how to work with that. Everything from Excel to analysis services all seem to work with that. Almost all the reporting tools I've ever run across usually have a connector to the cubes. So it's become sort of the great way to put this together. But one thing it brings with it is a semantic layer. Kind of gives you this sort of layer that keeps it out of the technical side and makes it more business friendly. So the business people can go out there and create their own reports based on what they want to know from that semantic layer over the top. So it gives us that one-stop shopping for data, keeps them out of the detailed systems like CRM and ERP. So the more advanced view of this same idea came along, and this is where we started playing with job schedulers, getting away from, say, SQL Agent and SQL Server and things like that, command files, whatnot, to move data around. Instead of that, we went for AutoSys or Control M or some of the others that are out there, these big job schedulers that would keep track of all the data movement throughout the system, throughout the enterprise. And that still is valuable today. It's still a great way to look at that. But we also brought in the idea of an ETL farm where you can actually have SSIS, for example, participate in a farm where we have sort of a controller and a worker node sort of concept where the controller hands off work to the nodes, and then the nodes go off and do what they're told, and if they fail, the controller will start a new one, things like that. So they're more sophisticated than they've been ever before. And then typically they end up pushing data all the way into the warehouse, as you might guess. And then again, with a semantic layer, we started to do more and more with partitioning in cubes, so we could do live sort of updates to the cubes that are near real time. A lot of those I've seen in the sort of 5-minute increment, about as fast as I've seen, but I'm sure there are others that are faster. So it kind of, used to be, we used to have to tear down the cubes entirely and rebuild them, and that takes time, and same thing. So this kind of gave us a way to do it in the daytime, live and in color, as it were. And having a cube farm, if you will, gives us the ability to work on one and slide it in place of the other, and all that sort of idea. Same thing with reporting services out on the right. That's showing out sort of the scale out strategy for reporting services, where we basically could host multiple copies of reporting services and have them act as one, and have them figure out, have the farm figure out who's busy and which one to hand a request to, and that sort of thing. All very interesting. So you can see how this has progressed over time to this sort of massive sort of system that works pretty well these days. As time moves on, we had scalability issues at times, taking in lots and lots of data, and as time has gone forward, we've gone from megabytes to gigabytes. Now we're in petabytes, and so our needs for data have shifted. And so now we kind of introduced the idea of using Apache Hadoop sort of ecosystem as a helper, to be able to expand SQL Server and whatnot, to be able to accommodate the kind of storage that we're talking about. Petabytes of storage is pretty difficult. I don't care whose OLTP system it is. So this kind of got us around those basic problems. It wasn't all fun and games. I mean, there were some serious things like learning how to do Uzi, which is a workflow engine, and get it ingesting correctly, and Flume and all these other pieces of our menagerie we call the Apache Hadoop ecosystem. This is what we wanted originally. We wanted this fast, really sexy machine to go and pull data together and make this fun and easy. And this is what we really got when we went to Hadoop. We got this sort of locomotive. And the difference between the two is that, basically, that Ferrari we looked at first was really great. It's fast off the line and can go, 200 miles an hour and that sort of thing. This big locomotive can't go as fast, but it takes a very long time to get those big wheels turning. But once those big wheels are turning, it's actually pretty efficient. So there are two different approaches to data management, and we've learned to coexist these things a little bit. This is kind of the overall reason why it's so slow. Is MapReduce isn't normally a very fast process with HDFS on the left, the Hadoop file system, then mappers that map a particular problem, do the partitioning over, and as you move through sort and grouping and through the reducer and then back to an HDFS. So basically there was a lot to get those big wheels turning, and it wouldn't necessarily work for a lot of our needs, but it could assist with some of the bigger needs. So we've started to think in terms of parallel sort of development about that same time, meaning MPP solutions, where we end up with multiple parallel processing going on and kind of combining the results. Along with that came Spark, and that's been an in-memory framework for some time now that's been out there in the wild. Very, very good at some things, and you may know it as Databricks, but before it was Databricks, it was Apache Spark, and the Databricks solution itself tends to have a big advantage in the fact it's cloud-based only. You can't install Databricks on a bunch of machines locally, and that is kind of a benefit. They manage everything in a sort of a SaaS sort of solution for you. Then there was a whole bunch of other projects that came along, and this is just a couple of them. I mean, we ended up with Presto from Facebook, Cassandra and MongoDB, and all these other things. Kind of with how do we move lots of big data around and be able to include it within some of our data warehouse activities. And there's more than that, by the way. Just a few to show you. This is again Apache Spark. Give you some idea of what we're talking about. This is the fundamental layouts. We have the SQL part of Spark and the Spark streaming. And then MLib, which is your machine learning library, which is what a lot of people are doing with Spark and Databricks right now. They've got this beautiful in-memory streaming sort of framework and the ability to go and run machine learning against that data on the fly is fantastic. And then GraphX is a graph database, and I won't get too deep into that, but graph databases are unique by themselves, being able to show relationships between different entities within there. So this was kind of the original thought that we had. You know, we had all these things kind of pulling together into Apache Spark, which would yield, you know, a fast in-memory engine. And then we had people like trying to use Spark for everything, right? So what you kind of find out when you do that is that Spark has its own limits. It has the fact that once you fill up whatever available memory you have, it spills to disk. And guess what? That's not very fast at some point. So it has great places where it's phenomenal and places where it's not. So it's just like any other technology, and that's such a bummer. So anyway, traditional Hadoop can outrun Spark in some cases. Remember I talked about those big train wheels and getting them moving. If you've got the kind of traditional batch that goes on for a lot of our processing, it might be better off under Hadoop to do some of that processing. So it just depends on your workload. Now enters Azure Data Lake Store. Now we're going to start the topics that sort of point to what modern data warehousing come to. So we talked about that earlier, just about HDFS, the Hadoop file system that is kind of ubiquitous. And at one point several years ago, Microsoft created, you know, our version of HDFS in the cloud, which is ADLS, Azure Data Lake Store. And we kind of went through two versions. We're on version 2 these days. So you can still do a version 1. For some tools still require it. There are a handful of tools out there that won't work with version 2, they only work with version 1. And that's, of course, going to stay around a little while until that goes away. But for all intents and purposes, you really want to be looking at version 2. It's based on blob storage, so it means it's a lot cheaper. And performance is really good these days as far as that goes. And it's the underlying storage for things like Power BI data flows, which I won't get deeply into that topic, but just know that even we at Microsoft are using Azure Data Lake Storage Gen 2 for things like that. And those are mission critical things. So this feeds into what we call our common data model and all that. So it's a fundamental piece of the new Power BI and some of the new features in Power BI. So anyway, so we've now got this ubiquitous sort of HDFS layer in the cloud where we can store almost an infinite amount of stuff and do it in a way that's performant. So this leads us to the sort of the master slide for modern data warehouse for Microsoft. You'll see this slide over and over and get them from us. Basically, it's showing on the left where we're ingesting logs, files, media, everything through Data Factory and eventually to the Azure storage. That's our ADLS. And then on the bottom, you see us pulling in data from those same things, those business apps and whatnot, through Data Factory, through Polybase. Both of those can end up as feeds into Azure Data Lake Warehouse. That's a sort of a different beast. That's an MPP solution of ours. We've been in the business of working on that since about 2011. We came out with PDW. Later on, that was renamed to APS. But what these things were big, giant appliances, physical hardware that sat on premise to do stuff, and where you had to have the ability to break apart big queries and big jobs. So you end up with a control node, kind of Hadoop style, and then individual worker nodes that would go out and do the jobs and come back. And so that's the kind of workload that Azure SQL Data Warehouse is good at. It's good at breaking apart big problems, and therefore it also needs big data, lots and lots of data to be useful. And where I see some people kind of taking a wrong turn with it is when we're talking about, very small amounts of data. When we're talking about 300 gigs or something, it's it could be still useful at that level, but it's like shooting a fly with a shotgun kind of stuff. You don't really need all that horsepower for a lot of things we do. And so in its place, we might think in terms of any other SQL Server sort of repository. So let's say you don't have that giant, massive amount of data to deal with, and we're going to be talking more about sort of the Kimball method, the star schema, running in maybe IaaS. Maybe you just haven't gotten there with us on the platform as a service side. You haven't tried Azure SQL Database yet, or any of that. So maybe you still want to do things in sort of a traditional way. You can do that. You can also host those very same things in Azure SQL Database. So depends on what your needs are and what your comfort level is. And then of course that ends up out into an analytics dashboard. We're assuming Power BI, but you might also be running Tableau or something else that can all those things can participate. So that's kind of the big picture of where we are for the moment. But as we went through, you start to see how do advanced analytics look in this sort of world where we have, again, the log files and unstructured data and the business apps on the right-hand side flowing through Data Factory, coming up through Polybase into Azure SQL Data Warehouse, eventually out through Azure Analysis Services. But also there's a piece of this one where we're actually pulling in Azure Cosmos DB, which is a big, think of Cassandra, MongoDB, any of those. Pretty predominantly they're key value pair sort of engines, if you will, that can do some pretty heavy lifting. And of course, one of the cool things about Azure Cosmos DB is a ring zero sort of offering, meaning it's available everywhere worldwide. Fantastic solution if you need it. Very low latency. It's a great solution for those who need it. And eventually, it pops out either through Power BI at the top or through a web app or both. That's kind of a really common picture for us at the moment. So as we go on a little bit further, as I mentioned, here we have basically the same idea. We're feeding apps and logs and everything through Azure Data Factory, storing in Azure Data Lake Store, optionally through, say Databricks there in the red. But that's not the only way. I mean, we could and still will see people that go straight from the business application database straight into some kind of ETL solution and eventually end up out in a star schema. And so it's not necessarily as complicated as this is. But we still see a lot of people that are still using the analysis services side of it, which gives you a great opportunity to surface data, in the sort of traditional way, in that we give you that kind of abstraction layer before it becomes out there in the wild. So I want to talk a little bit about Polybase for a minute, because we've been on this journey with Polybase for a very long time now. That's becoming really critical to a lot of data movement, not just Azure SQL Data Warehouse, which I have loved, by the way. It's a great product, and Polybase is kind of the easiest way to move lots of data into Azure SQL Data Warehouse, especially given that we have the distributions that have to be done. There's like 60 distributions under the hood within Azure SQL Data Warehouse. We can easily do some pretty complicated strategies with that using Polybase. But also in SQL Server 2016 and higher, we had the idea of data virtualization, which I'm going to demo for you here in a second. Let's take a second. And I'm going to switch over, and we're going to take a look at some storage I've got out here. Sooner or later it'll move. There we go. So I got a folder I called Energy under this blob storage account. It's got this little bit of data here, Energy Data Complete CSV. What it is just a generic sampling of meter readings from a utility company. This is open data that you can download. It's nobody's personal private data or any of that sort of thing. But as we go through, we can kind of see, we'll see the structure. I was hoping it would download quicker, but I'm having some network thing, probably because I'm doing a presentation in the middle of this. We can, yeah, we'll just move on and we'll let that catch up here in a second. But let's go over here. I've got a SQL Server instance running at the moment. I set up here a little bit ago. Hopefully it'll catch up here. I'm going to copy this and paste it, and don't think you're seeing anything magical here because I will wipe this out when we're done with this fun today. All right. Sorry, it's taking so long for things to spin up. Right before I had to present, of course, it wanted to update the server because I just built it and it was behind on patches and whatnot. So it's still waking up. All right. So I created this little database called App Data. Got a few tables, whatnot. Let's pull up some of the scripts I used to create some of this. Let's see here. So here's the basic code you can find out just about anywhere out on the on our demo sites and whatnot. They'll actually let you kind of try this yourself at home, whether it's SQL Server 2016, 17, or 19, it should work. You'll need that, and you'll also need access to an Azure subscription to be able to do this, obviously. You can also sign up for the free trial and get yourself 90 days, I think $200 worth of Azure credits. I think they're still offering that. But anyway, you can go out and try this where we can actually create, first thing you have to do is create this master key for encryption. And I just made some complex password that I won't remember after today. And then create a database scope credential. This particular identity I call Bob is because we don't use it for anything. We still need it, but we don't use it. Then we give it a secret. So we'd have to be able to pass all this around to make it work. And then from there we go and create an external data source. And this is kind of the location of the data that I'm looking for. As you saw, we were over in the Xenon Blob storage earlier. And then I call that, we'll call that an Azure storage credential, and we'll use that as we go forward. Here's an external file format where I'm basically saying, here's some stuff I'm going to use. It's just text files. It's going to use a string delimiter of double quotes, which is what that hex 0x22 is about. And then, that sort of thing. So basically, once I get to the definition of the table, I'm going to use these different pieces. I'm going to describe the table as external. I'm going to go down and give some kind of name to each of the columns. In this case, I'm just pulling in the data to look at it, so I don't care about the data types. I might in the future, but really all I want us to be able to do is query it. And then I'm going to tell where to go look for this stuff. And then I can pull it in. Now, I've run all this morning, so we should be able to run this if I change the database context to the right thing and pull straight from the table. So it's kind of fantastic that we can do this. Now, it's not warmed up or anything, so it's, as you can see, it can take a little time. Took 12 seconds to read 5,000 rows out of that raw text file that I've got out in blob storage. So as you get in here, you can start to see the external table definitions under here, and columns, statistics, all that stuff. This is something kind of akin to what we do in, say, Hive in Hadoop, where we describe a table as being external. I know it's something we can do in Oracle as well. So it's a kind of a ubiquitous sort of idea, though a lot of modern data engines are providing this sort of facility. So, and this whole idea is, sort of data virtualization, where we don't really need to move the data to do things. We can leave it on Azure Data Lake Store. We can point to it. We can do things like this and go out and play with the data a little bit and say, hey, what have I got here? And maybe even do a next step, which would be a create table as statement, to actually do all the data type enforcement, where I might go and say, hey, T1 is, a number, and it's, it's at least six digits wide, and 2 of it is a decimal point or something like that, where I can start to describe the data in more complete terms and have some form of enforcement going on. So anyway, that's what I'm talking about when I talk about data virtualization. Kind of prior to this, when we did Hadoop coupled with SQL Server, we were kind of stuck in a way with some older ideas of how to do data movement with that. We had to do, had to only come up through as a Java sort of a device in Java, and it was not pretty. It was also not very performant. This actually performs pretty well. And one thing. Are you sure? Sure. We can open this now, and sooner or later it'll come open. As you can see, it's a CSV, so it's going to pull in Excel to try to pull it up. Ka-chunk, ka-chunk. There it goes finally. So this is the data I was just playing with in SQL Server. It's raw data straight from HDFS / Azure Data Lake Store 2. And you can see it's just meter readings coming from a series of meters. And so, and a lot of times I go out and I try to find these sort of data examples that are open source that you can go play with. And I go all over the web looking for interesting data sets for us to use. Anyway, so that's kind of what's under the hood for that aspect of it. So let's return to our regular scheduled program. So data virtualization, why move anything? I like that dog. I had many bulldogs. So back to the sorry. Because one of the things that you'll find out with data virtualization is if for any reason that resource is down or changed or modified or something, it'll break. And so there's a cautionary tale with that. Also, you're bound to whatever current pressure that resource is under. And what I didn't say about data virtualization is we could point that same resource, instead of to text files on blob storage, we can also do it to Oracle. We say, hey, there's a table in Oracle, and here's the definition of that. SQL Server, you go point to this over in Oracle. Here's what you need to know to get there, and now present this table as local. We can do the same thing with SQL Server. We could do the same thing with Teradata. There's a bunch of different data sources we can point to this. But the downside is you're kind of expecting that the thing that's hosting the data for real is actually performance. So, it comes with a big caveat that, hey, you may or may not have enough horsepower under the whatever it is you're pointing to actually make this a fun sort of event. It could be slow. It could be non-existent. You could get an error. So data virtualization is awesome, but a lot of people, if it's a data thing that they really need a lot of the time, that they can be static, they'll do a create table as statement and pull it in as a local table. So it gives you kind of a way to move the data one time that way. It depends on your workload, right? So when it comes to modern data warehouse and that term, what does it actually mean, modern? Well, we're talking about added tools, some added tech, but we're still using star schemas everywhere. And star schemas are predominantly the way to go for most of this, I think. And that's my opinion. That and 50 cents won't get you even coffee at Starbucks or something. But anyway, so just know that it's really, sort of a term, but it's not necessarily meaning anything, very different in the thinking behind data warehousing and why we do it and how we approach it. It's just that we've added some additional things like Hadoop, we've added things like Azure Data Lake Store, and we've added Spark, like our friends at Databricks, Azure Databricks. So but we're still dealing with our good old friend the star schema as a rule. So we get this question a lot: why have a data warehouse? Can't I just have a cube? So, and the kind of the answer is cubes are often department level, right? So they're not meant to be as often as enterprise level. Depends on, there's no set things here. But it's also easier to join and clean in the MDW. And cube processing, depending on size, can be very slow if it's really, really big. And some of this is, well, maybe we should have partitioned the cube and looked at doing things in a smarter way. Some people are just learning. Sometimes they have some kind of constraint where they don't find that that's useful. So you kind of find a lot of reasons why people don't do things. Cubes also don't have all the data. They have just a summary piece of the data. And we don't really support anything known as a slowly changing dimension that we would see in traditional star schemas, right? If you're familiar with that, you know that basically we're holding on to all the changes as they happen so we can actually kind of see over time how the changes happened. And we're big on that in dimensional modeling and data warehousing. What has changed? So why do I need a cube if I have a data warehouse, right? So, okay, you can go the other way. The semantic layer, think of it that way, is that one of the benefits is that semantic layer. And also we can host a large number of concurrent users, in the thousands sometimes on a cube. So, it's cubes themselves are not organized like our current SQL Server, Oracle, any of those offerings. It's a very different beast. And it doesn't work the same and it doesn't behave the same. So it's just a very different beast. We also do the aggregation for performance reasons, where we'll pre-aggregate things and get them kind of spun up for in anticipation of the questions people are going to ask, like number of sales per quarter kind of questions. We can aggregate things and make hierarchies out of things and kind of presume a lot. And a lot of times it just comes with experience and seeing what people ask of cubes. Sometimes cubes are also required for some reporting tools. Like it may not be the only path to use the reporting tool, but it's the fastest or maybe the best way. And there's no need to join a bunch of fact and dimension tables because we've done that already as part of the cube processing. So that's kind of why we tend to have both of data warehouse and cube. And then, of course, why use Spark from Databricks? Well, if we have the right workload where we can fit all of the processing steps in memory, this is awesome. It is fast. But if for whatever reason, you've got, say, half a 500 gigs of memory on an available system, and you've got a 2 terabyte workload, guess what's going to happen? It's going to spill the disk, and it won't be very performant. I think we covered that earlier, but so it's great where it works, and it works often. So Python and R resources within Spark, especially Databricks, is awesome. Also, Databricks does support using notebooks, if you're familiar with those. It kind of gives us a way into that sort of data ops sort of way of being able to share resources like notebooks with other people, start putting them under source control onto GitHub and whatnot. So we start to have a DevOps story around that, or data ops story, depending on who you're listening to these days. So there's some good reasons, and those are kind of it. So there's a lot of resources out there, like comparing multidimensional, tabular, whatnot. You can kind of look for some of these resources yourself, get some idea of, kind of what's available. With that, ready for any kind of questions people might have.
Sure. Someone wants to know, when is Polybase not a good choice?
It kind of goes to what I just mentioned about, trying to do data virtualization. If that resource is going to be offline for some reason, yeah, data virtualization is maybe not your best choice. So, and if you're trying to move data really into Azure Data Lake Warehouse, Azure Data Warehouse, you've got the same problem. Polybase is really the easiest, most standard way to move data. So, next.
How does the reject rows, etc., display with this external table?
How does the reject rows? I'm not sure what they are asking.
Okay. What options exist for querying directly against the data lake?
Well, like I pointed out, we can use Polybase and SQL Server to do data virtualization to do that. We can also attach HD Insight to it and use Hive as another way. We can also attach a Cloudera cluster against it, an existing Azure Data Lake Store, and use things like Impala. And then, of course, there's Presto. There's all these other animals in the Hadoop world that let us do those kinds of things.
All right. Does anybody else have any other questions? You do put them in the questions panel or in chat. We'll give you guys just a couple minutes.
Sure.
How do you handle null values when using Polybase to load SQL DW?
So in that case, you'll notice that I didn't do anything, actually. And if I go back to the demo here, you can do several things. Like on this select, like any other select, I could be doing a is null statement or whatnot to try to trap for that on this query and eliminate null values, or at least provide some kind of value for them if I wanted to. So I'm just pulling back the basics here. I'm not even trying to do any transform, but I could be. I could be using is null and whatnot to try to, change up what happens where the values are null. The usual suspects.
Okay. Are you saying Cube's tabular models, I'm assuming, can support large number of concurrent users, or you're referring to the Azure Analysis Services?
So I'm talking about Azure Analysis Services plus tabular model cubes can support large numbers of users, yes. And of course, this is all relative. We say all, that's a dangerous word. I mean, if we scale it up to enough to be able to manage that, yes, it'll handle thousands of users.
With respect to the modern data warehouse diagram, I assume the ETL populating the fact table lies in the ADF. What is the difference between the ADF and Databricks ETL? What is Bricks doing that ADF isn't?
It's just different technologies. I mean, if you can do it in Azure Data or Azure Data Factory, you kind of think of that in terms of as a sort of replacement for a lot of my customers who are very used to SSIS, which we support in Azure Data Factory. Well, if you've done that, there's an infinite number of choices we have for manipulating data. Whereas in using sort of the Databricks approach, you don't quite have the toolbox that you got in something like Informatica or SSIS or whatnot, but you've got a pretty good robust toolbox there to do basic transforms and test for nullability and whatnot. So they're just not the same technology and the same tool set. That's just the way to look at it. One is based on sort of an open source Hadoop sort of project that has a certain group of fundamental capabilities, whereas Azure Data Factory is a little different in that it supports a wide variety of ETL solutions that will help us do that.
Okay. I'm expecting lots of banking transactions from our source systems. Would Databricks be a good choice to process this?
Absolutely. Databricks is a fantastic choice for high speed, easy to use, secure ways to move things. So yeah, I wouldn't be afraid at all to use Databricks in that capacity.
Would Azure Data Warehouse prefer a big wide table instead of traditional fact tables plus many dimension tables?
I don't like big wide tables as a rule. I mean, just as having done this a while, that comes with a lot of stuff. Like, okay, so we have a date dimension table, and it's got, we'll say, 50 columns because we want to describe all the ways a date can be. That's still not a wide table. I've seen customers, have 400 columns on a table, and that it comes with a ton of overhead every time you pull anything back with no filter, select star from kind of stuff. Then you're paying that price that you don't need to pay. So I'm not a fan of using indiscriminate wide tables to accomplish things.
Okay. For the external table, when you read a file on Azure Data Blob Storage, if the rows in the file don't match with the structure of the table, where do such records direct to?
So if I misdescribe the layout of a piece of say a CSV file like I was using there, what will happen if, like, say, if I have too few columns, it will throw an error if I don't have the right numbers of columns described. So there's some limits there. But that's about it, really. Especially the way I did it, where I just said everything's a varchar 25. That's kind of a lazy man's way out. But all I wanted to do was explore the data. I didn't want to spend time figuring out what kind of the data type. So it's kind of up to you, I guess.
Is there any particular data that Databricks is not good for?
I mean, I don't want to pick on Databricks specifically. Well, I'm going to say Spark, where Spark really sucks, is big batches that are bigger than memory. That's the thing to watch out for. If you can't break up the work in batch sizes that they can manage, now realize that if you're talking about Databricks, they've got their own Delta Lake and they've got some other cool features they've added. I kind of think of them a little bit like Cloudera. Cloudera always was the leader, in my opinion, on Hadoop technologies for enterprise purposes, because they understood security, they understood the need for backups and things that we kind of expect out of enterprise systems. Whereas raw Apache Hadoop wasn't necessarily a good choice for some of that. And so it's kind of the same thing with Azure Databricks versus just straight up Spark. They add a lot of stuff to their mix that is not out of the box if you go and get Apache Spark. And so that's where they really shine. So I would look to them if you're thinking of doing anything in a really business-like way with security in mind and encryption in mind, all those things. Look to them. They do a good job with that.
Okay. What do you think of using Power BI data flows to augment a data warehouse?
Well, it's kind of different topics. I like data flows. They can assist with providing that common sort of data model between things. So personally, I like the idea of the data flow. I don't know that it really augments anything to do with a warehouse, but it does. I guess you could see it that way. So yeah. Anyway, I'm a fan of data flows for where they fit, and for being able to put the data together in a routine way. Yes.
Is the only way for Azure SQL DB to interact with ADLS v2 via external tables?
So Azure SQL Database itself does not support Polybase, so it can't do any of that fun stuff. Period. There are only two products we sell that work with Polybase. One is Azure SQL Data Warehouse, and one is SQL Server. And the SQL Server, of course, is going to be an IaaS solution, and from IaaS. So basically, we're talking VMs running SQL Server.
All right. Since Azure Data Warehouse is MPP, does it perform well if we join a fact table with multiple dimension tables on different columns?
Depends. MPP is fantastic for the right problem set, where we're going to take a lot of data and do some serious querying and movement of the data. MPP just can't be beat for that kind of problem. I mean, I've personally seen workloads go from, a couple of days down to minutes using Azure SQL Data Warehouse, but those were specific workloads with a specific problem. And that's the problem, is that your mileage may vary. If you've got the kind of problem and the kind of data volume that's involved, it could be huge. I would say anybody thinking about it should get out and try it and see if it fits for what you're attempting.
Okay. Give everybody just a couple more minutes to see if there's any other questions, because I know last time I asked, a lot came through.
Okay, cool. Yeah. There's plenty of material out there too on this topic that you can read. I mean, I like to follow people like James Serra, who I think you've got speaking later today.
Yep.
He's fantastic in this area. So if you want to follow him, there are a number of those kinds of resources, but James is one I use myself. So just know that there are lots of opinions out there, but he's one of those people I really respect. So look for his blogs.
Yes, he's got a lot of good
people.
presentations and stuff out there.
Yeah, he's fantastic, and he's been around a long time. So
yes.
It's nice to have that consistency over time.
Yes. I think he is another PW alumni too.
I think he is. Might be, yeah.
All right. Well, it looked. Oh, here we got one more. Is there a good course on Databricks that you can recommend?
There is. Databricks themselves has I think it's called Databricks University. I would go to them because they have some really comprehensive training that's fantastic, and it's not unfairly priced. I think it's all online. I think you can go somewhere and actually do it in person, but for the most part, I'm aware that it's online, and I've actually gone through some of that training myself and really, really like it. So. Of course, our friends at Pragmatic Works may eventually have something. I'm not aware of it.
I was about to do a shameless plug. We actually just became a Databricks partner, and we will be releasing the Databricks course, I think, in the next month. So
fantastic.
And it is an introduction. So if you already kind of have something, have an understanding, it might not essentially be the right fit, but our courses are very in depth.
Yes, they are. Yes, they are.
All right. Well, I think that is it. So thank you guys so much for joining our third session. Roland, thank you so much, as always, for presenting. We always enjoy having you back at PW in some form or fashion. So you guys, the next session will be starting in about 6 minutes. If you need anything, we are here. And thank you all very much.
Thanks, guys.
Thanks.